Hey everyone! So this week we would have been going on a tour of the acoustics facilities at BYU. Since we can't do that, we're just going to learn a little bit about acoustics. So today I'm just going to talk to you about a few things that I think you'll think are cool. I think they're cool. Um, just kind of some basic things about the science of sound. So if I can get my PowerPoint to go forward. There we go. Okay, so first thing you need to know is that sound is a wave. Um, and it is a different kind of wave than, say, light. It's a pressure wave and it's caused by an object vibrating. In order for this wave to propagate or move, it needs a medium to travel through. That means it needs to be traveling through something. It can't be traveling through nothing. So it can travel through a gas or a liquid or a solid, but it has to travel through something. So knowing that sound needs a medium, I'm going to show you a clip from a very popular video or movie. um, but it's had some alterations made to it, and I think you will be able to figure out why it's a little bit different than you're used to seeing it. So just watch this for a second.
The possibility of successfully navigating an asteroid field is approximately 3,720 to 1.
Never tell me the odds.
Okay, so you notice there was no sound when that ship hit the asteroid. Or that one. Or right there.
Said you want to be around when I made a mistake. This could be it, sweetheart.
I take it back.
Okay, so that's enough of that. Now, I'm not going to answer this question, but I want you to think about why the Star Wars movies really should not have any sounds with the explosions that happen in space. Why would there not be sound there? So think about that. Okay. Next thing I want to talk about with sound is something called frequency. So with sound, we measure how often the particles of whatever the medium is are vibrating with something called frequency, and we usually measure frequency in hertz. So if you are into music at all, you may or may not know that each musical note has a specific frequency. So like there's different A's on a piano keyboard, and like the kind of central one has a frequency of 440 hertz. You can see they go up from there. So different notes have different frequencies. Something that's really interesting to look at and learn about is the different pitches or frequencies that different animals can hear. So humans, we can hear anything between 20 hertz and 20,000 hertz. So you remember those like normal notes on the piano in the middle of the piano are around like 440. So we can hear quite a bit lower than that and quite a bit higher. But it's just kind of interesting to look at this chart, and you can see, for example, dogs can hear a lot higher frequency than we can. And I'm sure you've heard of people using like higher frequency sound generators to um, train or keep dogs away from places. Cats can hear even higher than dogs. You'll notice bats can't even hear almost anything that we're hearing. They're hearing like an entirely different range than we are. Dolphins have a really big range. And then interestingly, elephants can hear below our sound threshold. So they can actually hear what we call infrasound, which is like sound below sound. So that's kind of cool, kind of interesting, just to look at the different ranges for different animals. My video is kind of in the way of this, but down here at the bottom it says most humans can distinguish pitches that differ by as low as 2 hertz. So we can distinguish between something that's 440 hertz and 442, especially people that are into music. Now, objects can vibrate, and when they vibrate, they will produce a sound, and that sound will be at the natural frequency of the object. So some objects have just one frequency that they vibrate at, like a flute. But a lot of objects have a lot more frequencies than just one. Like a pencil, if you drop a pencil, it doesn't sound very musical. It's got a lot of frequencies that are going on in that. So I want to show you a video of a water goblet vibrating at its natural frequency. You can go home. You're already at home. You can do this. It looks like this. Okay, we're gonna stop there. So you'll notice he said the natural frequency depends on the speed that sound travels through the object. So he can actually change that later on in this video. He changes the amount of water, which changes the speed that the sound travels, which gives us a different pitch. So this is something you could play with, putting different amounts of water in goblets and listening to the different sounds that that makes. So another thing you can do is change the speed of sound by lengthening or shortening the length of a string on a guitar. So that's how guitars work. They change the natural frequency of the different strings by making them longer or having different tightness or density. All of those things affect the speed of sound. And that's how a guitar works. Another thing that I wanted to show you that's really interesting, to me at least, is that if you have one object that is vibrating at its natural frequency, so giving off a sound, and there's something else close to it that has that same natural frequency, that other thing will start to vibrate and have that same sound. So the video I want to show you, actually I might show you two videos. This one, they're going to hit a tuning fork, and it's going to vibrate at one frequency, and then a tuning fork next to it is going to start vibrating because they hit the first one. So there's the first tuning fork, it's vibrating. And then I don't know if you could hear, but when he stopped this one from vibrating, you could still hear the sound. And that's because this other one was vibrating right here. I'm going to show you one more example of this. It's kind of weird. They're going to just take these horns and play them really loudly. And the piano strings that correspond to the frequencies that these horns are vibrating at are going to start vibrating and making noise. So some of that might sound like the blowhorn, but a lot of this sounds like a piano. Like those pitches sound like a piano. And that's because the piano strings are actually vibrating. The ones that correspond with the frequencies of those horns. Yeah, so I think we'll end there. That's about 10 minutes. So those are just some interesting things about sound. We're going to be talking about this a little bit more next time. And yeah, there's a lot of sounds in your life, so you can kind of step back and start listening to the things that you are hearing and thinking about all of these different things about frequency and resonance and um, what else did we talk about? Frequency and resonance and how sound travels. So Hope you thought this was interesting, and I hope you guys have a good day.